Yeah, so we're getting into 2.4 now, so exponent laws. Good news is, so we're going to do 2.4, we're going to do some exponent laws, and then 2.5, some more exponent laws, and then just putting it all together. And this is actually just making like our toolkit bigger. So then when we start doing order of operation stuff, we're just going to be able to kind of make things simpler with some of these exponent laws along the way. All right, so...
So is a law that like when it's a 0, then it's always 1?
Well, that was a law. That was a law, yeah. This is going to be like a different kind of law. But yeah, you're right. That when we had like a to the power of 0 is equal to 1, that's also, if you can call that a law in math, right? And a was like any number.
Was this not on the test?
It was, yeah, already. But anyway, so when we're talking about laws in math, we just mean something that holds true all the time. That's what we mean by a law. So let's say if we had like a situation like 5 to the power of 4 times 5 to the power of 2. Well, do you guys remember what it means to write something as a power? That's really 5 times 5 times 5 times 5, right? That's 5 to the power of 4. And then if I go times 5 to the power of 2, that's really just 5 times 5, right? That's 5 to the power of 2. Can you guys see, like, what could I rewrite this as? This would be the same thing as just...
5 to the power of 6.
Yeah, 5 to the power of 6. So if that's 5 to the power of 6, you guys can probably make up this first law. What did we do with these exponents? We just added them, right? We just added them. That's going to be our first exponent law. We just, well, would this work though? If I would have had, let's say, 4 to the power of 4 times 5 to the power of 2? That one won't work, right? Because that's not the same thing. That would have been, you know, they have to be the same, right? They got to be the same base, right? So it's got to be 5.
4 times 4 times 4 times 4 times 2 times...
Well, yeah, because this one would just be 4 times 4 times 4 times 4, and this would be 5 times 5, right? I can't write that as 5 to the power of something, and I can't write it as 4 to the power of something. I just have to keep those things separate.
What you have to do is you have to figure out the 4 to the power of 4 and then 5 to the power of 2, and then you have to times those.
That's the only thing you can do when they're different bases, yeah. Yeah. Okay, so let's move on. So officially, here is your first exponent law. So it's written like this. It looks a little bit more complicated, but this is saying a to the power of x. Here, I'll write it out again, and then so a to the power of x, and then this x means times. I'll write it as a dot so we don't get confused. A times a to the x times a to the y is equal to a to the x plus y. That's like a fancy math way of saying the same thing, right? It's saying if the bases are the same, do you see how the base is a for both of those? A just means it could be any number. That could be like 4, that could be -2, that could be anything, right? So it's just saying if the base is the same there, then, and this one had some exponents, so again, that could be like 2 or something like that, and that could be 3 or whatever. They're just saying the rule here is that you'd have the same base in the end, right? Still a, but then you add the exponents. So I know that looks confusing, but that's just like a mathy way of expressing it. And I'm going to explain it like that as we go along the way, especially like, you know, math 10 and everything else, because this is almost like a math language that we have to get good at speaking, right? So even though it was pretty simple, just add the exponents, I can just say that out loud, I have to make sure that you guys understand how to read that in Mathanese.
Mathanese.
Japanese is the new language.
Okay, so that's really it. So let's see if we can do a few of these. Well, here, I'm going to pause it. See if you write some answers here. You guys should be able to get some of these right away. So, okay, so the first one here is going to be 6. The base is 6, right? So, and they have to be the same for us to do any of these laws, right? So it's going to be 6 to the power of 9. How'd you guys get 9?
5 plus 4 equals 9.
Right, we just added our exponents. 5 plus 4, so that's 9. There you go. That easy, right? Okay, let's do the next one. This would be 12, right? Same base, so 12 to the power of 4. Okay, and that's true, but let's even think about this another way. We could have thought about that a little different. 12 to the power of 0 times 12 to the power of 4. What was 12 to the power of 0?
1.
Yeah, so if I make that 1, that's like 1 times 12 to the power of 4. So that's 12 to the power of 4, right? 1 times anything is just a cell. So you could have thought of it that way too, right? It's still...
It said 0 plus 4 equals...
Yeah, and you can do that, right? I just wanted to show you that we're doing the same things as we did before too. It works. All right, next one. What's our base going to be on this one?
-2.
Yeah, -2. Yeah, so it's going to be -2 to the power of 9.
Again.
You guys are getting good at this. All right, next one. What's my...
-5 to the power of 9.
All right, so I got -5 to the power of 9. Anybody get anything different on this one?
I got 5 to the
Oh, do you have to put brackets or something?
No.
There's something to do with brackets here. Yeah, there's something fishy
Well,
going
there's
on.
no brackets, so like it would be positive.
What?
It just be 5 to the power of 9.
That's what I said.
I didn't write that, but I just figured that out.
Okay, here's why. Like, I know some of you guys are confused, but again, it's one of those tricky bracket situations here. So what's happening here is this is really like negative, right? The negative is just tacked on the front of 5 to the power of 1. If you want, you could have put brackets like this, right? Like on all the way around the outside. Times, and then this negative is just tacked on the front as well. You could think of it this way.
Yeah.
So this is really like, what do you get if you go a negative times a negative? A positive, right? So this is really going to be positive 5 to the power of 9. Did you guys get that? It would have been different if there was brackets here.
That equals 200.
That would have been different. That would have been a base of -5 to the power of 9. This one is just, again, because it's just the 5 to the power of 1 and just the 5 to the power of the 8, or power of the 8, power of 8. And then the negative is just tacked on the front. Does that kind of make sense? So then you just got a negative times a negative, ends up giving you a positive. Very, very easy place to make a mistake is on these ones, right? When they have them written this way.
Yeah.
So just be careful. Practice those ones. Yeah, okay. So, oh, yeah, sorry, that one wasn't -5 over 9. Should change that.
Positive.
Positive 5 to the
I'll
9.
just add a line to my negative.
Oh, there you go.
I was right.
Okay, the next part of this is if we had something like 5 to the power of 4, and I'm going to write this instead of like divided by, like with that symbol. As you guys keep going up in math, we typically write divided by as over, like write it more like a fraction. So 5 to the power of 4 over 5 to the power of 2. And now what I'm going to do for this one is I'm going to write these out again. So this would be the same thing as 5 times 5 times 5 times 5 over 5 times 5. And does anyone see what's going to happen here?
You can cancel
Oh, you
out
just,
two
it's
fives.
going to be.
Yep,
Yeah. Yeah, you.
you can cancel out like 2 of the 5s at the bottom of the 5, so then you can put 2 5s at the top.
Yeah, do you guys see that move, right? I get to cancel one of those 5s with one of those 5s, because 5 over 5 is what?
5 for 1.
It's 1. Right? 5 divided by 5 is 1. So when I cancel, remember what I'm doing. I'm turning it into 1, right? Because 1 you don't really have to write. 1 times anything is just anything. Okay, so I cancel those ones, and then I get to cancel those 5s. And what do I have left up top now?
Times 5 times 5.
Yeah, I've just got 5 times 5 left.
Or you can subtract the exponent.
I've just got 5 times 5, so that's the same thing as 5 squared.
All at 25.
Okay, so that being said, what was our rule then? If we come back here, if this was equal to 5 squared, anybody have any guesses on what our new rule is going to be?
Just
Yeah,
Subtract the exponent.
we're going to subtract the exponents, right? Which is kind of what you think anyway. Like, if do you guys find this too, that multiplying and adding are kind of similar, and then dividing and subtracting are kind of similar? Like, they kind of belong together.
no.
It's the same type of thing. Like, multiplying we add, dividing we subtract, right? So, and that's gonna be it. Those are our first 2 exponent laws. So that's it. So officially we can write it out like this: a to the x, so any number to the x, divided by that same number, the base has to be the same, over some other number, is equal to a to the power of subtracting those 2 exponents.
So you were right on this.
So, can you write a negative exponent? Like,
Ooh,
let's
good.
say it was like a to the power of 4 divided by a to the power of 8. Would it
Well,
be-
I'll skip a little ahead. Since that's your question, can we have negative exponents? Yeah, it turns out we can. We don't do that much like in Math 9. Like, I won't really have these on any of your assessments. But Math 10, like 10C, we do like a ton with negative exponents. So this would be a good example, right? What if we had 9 to the 1 divided by 9 to the 8? if our rule is that we subtract exponents, we're going to end up getting a negative number here, right?
Yeah.
And what we get if we wrote this out, this would be like 9 over, and then you'd have 8 9s in the bottom, right? 9 to the power of 8. One of them would cancel on the top with one of them on the bottom. And we'd end up with 1 over 9 to the power of 7. And it turns out that negative exponents, if I wrote like 9 to the power of negative 7, that actually just means it's called a reciprocal. And that negative exponent actually just flips it upside down. So if it was 9 over 1, it becomes 1 over 9. It gets a little, I know it's confusing, that's why we're not going to do much of it in grade 9. But another way of saying this too is like 1 over 9, that's a decimal. So once you start getting those negative exponents, you're really talking about getting decimals. Okay? All right, so go back a little bit though. Let's try some of these. So can you guys, I'm just going to pause it and you can try these ones. So careful with some of the negatives and brackets there, which is nice. Okay, so let's do 8 to the power of 5 divided by 8 to the power of 3. So our rule when we're dividing is we do what to the exponents? We subtract them, right? Which you're really canceling out is what's happening there. But quick and easy, we subtract exponents. So that would just be the same thing as 8 to the power of 2. Right? Now, and just think about like why this is going to be useful too, right? Like if I would have been given this question, this question, that would have been a long question to do, right? Especially if it was like by hand. If I said do this one without a calculator, you would have had to have gone 8 times 8 times 8 times 8 times 8, and then figure out what that is, and then divide it by 8 times 8 times 8, right? Like that would have been terrible. This is way better, right? We just simplified that down to 8 to the power of 2, which is really just 64, right? Like that was neat. Like that's why this is useful, is because we can actually, you know, make our equations a lot simpler and then solve them. All right, next one. 2 to the power of 6. Oop, that's 26. 2 to the power of 6 over 2 to the power of 0. What would that be?
2 to the power of 6.
2 to the power of, yeah, 6, because 6 minus 0 is still 6. Now, again, let's just see if this makes sense too, right? 2 to the power of 0. What is anything to the power of 0?
1.
That's really 1. So this was always just 2 to the power of 6 over 1. And anything over 1 is just itself, right? That's still just 2 to the power of 6. So either way, you can think about it in both terms, right? Okay, next one. Negative 4 to the power of 7 divided by negative 4 to the power of 2. That would be,
Negative 4 to the power of 5.
yeah, with the brackets too, right? Negative 4 to the power of 5. Just subtracting 7 minus 2. Now, let's see if you guys can get this one. What would this be? First off, negative or positive?
Negative.
All right, how many people say negative? Oh, sorry, Wasey.
Well, it's on another one.
And it's for the same reason as the last one, right? It's because there's no brackets there. If there would have been brackets like this, then it would have been negative 9, because then it would have been negative 9 to the power of 1 and negative 9 to the power of 8. But this is really like negative 9 to the power of 1 and negative 9 to the power of 8. And then what do you get if you go a negative divided by a negative? You get a positive, right? So this is going to come out positive. So this will be 9 to the power of, what's this?
Negative
7? Yeah, negative, good. Yeah, negative 7. Again, I'm not going to do this to you guys very often. I just kind of do this just to show you that it'll still work. Can anybody tell me from what I just did in the last page there, when I was just showing you, what would this be the same as? Yep.
9 over 8, or 8, 9 to the exponent of 8 over, no, it's 1 to the,
That would technically be the same as 1 over 9 to the power of 7.
Oh, because the answer is just
I got 1 right.
So it ends up being a really small decimal in this case, right? Like it's 1 divided by a really big number, so it ends up being a really small decimal, like 0.00000 something. Okay, so that, yeah, we just did that. Okay, you know what? I'm